So now that you have learned about derivatives, even if we still haven't learned about implicit differentiation and logarithmic differentiation, which we'll learn about later, please check the previous video about derivatives and their proofs in order to at least look at the rules about the derivatives. Even if you don't understand all the proofs, just check out the other video for the derivatives that you should know. And this is why now we will move to a few examples. We will start with basic examples and then increase difficulty. So, first of all, these examples come from page 181 in the book. So let's start. Suppose g of x equals to 4x plus 7. Let's find the derivative of g of x. Now, let's start with 4x. 4 is a constant. We keep it out. X is x to the power of 1. Let's do the power rule. We drop the power, and then we take x to the power of 1 minus 1. And this is the derivative of 4x. Now 7 is a constant, and the derivative of a constant is 0. So this is in fact our answer. We will simplify it slightly. So 4 times 1 is 4. 1 minus 1 is 0. So x to the power of 0 is 1. So this leaves us with 4 as our answer. And the next example we will look at is f of x equals to x to the power of 75 minus x plus 3. The derivative of f of x. For x to the power of 75, we use the power rule. We drop the power and then we do x to the power of 75 minus 1. Now for x, this is x to the power of 1. So we drop the power and we do x to the power of 1 minus 1. And for 3 is a constant and the derivative of a constant is 0. Let's simplify this slightly. 75 minus 1 is 74. And x to the power of 1 minus 1 is x to the power of 0, which is 1. And this is our answer. Now let us move to another example. F of t equals to negative 2e to the power of t. What is the derivative of f of t? So, 2 is a constant. We keep it here. What is the derivative of e to the power of t? So, we agreed in the previous video that the derivative of a to the power of x is a to the power of x times ln of a. So the derivative of e to the power of t is e to the power of t times ln of e. And you can plug this in your calculator for ln of e. Ln of e gives 1, so we can write this as negative 2 times e to the power of t. Now let's move to another example. So if w of v equals to 1.8 v to the power of negative 3, what is the derivative of this function? So first of all, we keep the constant outside. V to the power of negative 3. To find the derivative, first of all, we drop the power and then we subtract 1 from it. So this is 1.8 times negative 3. V times v to the power of negative 3 minus 1, which is negative 4. And we can multiply 1.8 times negative 3, which gives negative 5.4 v to the power of negative 4. Now let's move on. If we have s of t equals to negative 1 over t plus 1 over t squared, what is the derivative of s of t? So I will start by rewriting s of t. Instead of writing 1 divided by t, I will write t to the power of negative 1. And instead of writing 1 divided by t squared, I will write t to the power of negative 2. So now I can use the power rule. For the first one, I keep the negative sign outside, and then I drop the power, and then I subtract 1 from the minus 1 in the exponent. I do the same thing for the second one. I drop the power, which is -2, and then I subtract 1 from the exponent. This leaves me with -1 times -1 is +1 times t to the power of -1 minus 1, which is -2. For the second one, this gives -t to the power of -2 minus 1, which is -3. And this is our answer. Let us proceed. If we have y equals to 2x plus square root of x, what is the derivative y prime? First of all, I will rewrite y as 2x plus, instead of square root of x, I will write x to the half. Now I will take the derivative. The first term to x, I leave the 2. This is x to the power of 1, so I drop the power 1, and I get x to the power of 1, and I subtract 1 from the exponent. I do the same thing for the second one. I drop the power, and then I subtract 1 from the exponent. So that this leaves me with 2 times x to the power of 0. X to the power of 0 is 1, so I don't have to write it. Plus half times x to the power of half minus 1, which is -half. And this is the answer. Now, I will move on to a few other examples that come from the page 189 in the book. So let's start. If f of z equals to 1 minus e to the power of -z times z plus e to the power of z, find f prime of z. We can see that we have first term and the second term being multiplied, so we can use the product rule, which says that I keep the first term times the derivative of the second term plus the derivative of the first term. So these little prime signs mean derivative. So plus the derivative of the first term times the second term. What does this give us? So 1 minus e to the power of -z. Now I'm finding the derivative of z plus e to the power of z. So the derivative of z, or z to the power of 1, I drop the power 1, times z to the power of 1 minus 1, which is z to the power of 0, which is 1. And we already established from previous derivatives that we have computed here that the derivative of e to the power of z is, it stays the same, it stays e to the power of z. Now let's find the derivative of 1 minus e to the power of -z. So what is the derivative of 1? 1 is a constant, so its derivative is 0. I don't really have to write it, but let's write it for now. So what is the derivative of e to the power of -z? So, first of all, we know that the derivative of e to the power of something stays the same. But what if this something is -z, not z itself? So now we can use the chain rule. So I take the derivative of the function at -z, and then I take the derivative of -z, and the derivative of -z is -1. So now I can slightly simplify it. I don't have to simplify a lot. What I can remove the 0, no need to write it. And here I have a -1 times a -1. This becomes positive e to the power of -z times z plus e to the power of z. And this is our answer. And let's look at another example. So let's say y equals to e to the power of p times p plus p square root of p. So let's find y prime. Again, these are a first term and a second term being multiplied. So let's use the product rule. So I keep the first term the same and I multiply it by the derivative of the second term plus the derivative of the first term times the second term. So what is the derivative of p plus p square root of p? First of all, I will rewrite this as p plus, this is p to the power of 1, and instead of square root of p, I can write this as p to the power of half. And what do I do with p to the power of half and p to the power of 1 multiplied? They have the same base. So I can add up the exponents, and this becomes p to the power of 3 halves. I need to take the derivative of this, plus the derivative of EP, e to the power of p, times p plus p square root of p, which is equal to e to the power of p. Now what is the derivative of p plus p to the power of 3 halves? So first of all, the derivative of p to the power of 1, again I drop the power, I do p to the power of 1 minus 1, which is p to the power of 0, which is 1. And now for p to the power of 3 halves, I drop the power and I do p to the power of 3 halves minus 1, which gives half. I continue. We already established that e to the power of something it stays the same times p plus p square root of p. And this is our answer. Given the function f of t equals to x squared times e to the x divided by x squared plus e to the x, let's find its derivative, and since this is a fraction, we can use the quotient rule. So we do low, the denominator, d high, so low times the derivative of the numerator, as I wrote, minus high, so the numerator, times the derivative of the denominator. All of this divided by the denominator squared. Now let us start computing these derivatives. So x squared plus e to the x stays the same. Now we want to find the derivative of x squared times e to the x. And I just said times. This is a product, so I can use the product rule. So I do the first term times the derivative of the second term plus the derivative of the first term times the second term. And now let's continue. X squared times e to the x stays the same. And I need to find the derivative of x squared plus e to the x. And I keep the denominator the same. So let's look at what I changed here. So the derivative of e of x is e of x. And the derivative of x squared, I drop the power, so it becomes 2 times x to the power of 2 minus 1, which is 1. Now let's look at the derivative of x squared plus e to the x. Derivative of x squared plus e to the x is, we have the addition of two terms, so derivative of x squared is 2x, and the derivative of e to the x is e to the x, and the denominator stays the same. And unless you're asked to simplify, you can keep your answer this way. Now let's look at a few more examples, this time from page 197 from the book. So f of theta equals to sine of theta divided by 1 plus cos of theta. Again, we have a division, so we can use the quotient rule. So to find the derivative, the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator. All of this divided by the denominator squared. So let's compute the missing things here. This is equal to 1 plus cos of theta. The derivative of sine of theta is cos of theta minus sine of theta. The derivative of 1 plus cos of theta, first we find the derivative of 1, which is it's a constant, so the derivative is 0. Now the derivative of cos of theta is negative sine of theta. All of this divided by 1 plus cos theta all squared, and this is our answer. Let's move to another example. Let's say y equals to x divided by 2 minus tan of x. Again, this is a fraction. Let us use the quotient rule. So, the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, all divided by 2 minus tan x, all squared. So, let us find the missing derivatives. What's the derivative of x? This is x to the power of 1. The derivative of x is 1. Minus x. What's the derivative of 2 minus tan x? Let's start with 2. 2 is a constant, so the derivative is 0. Minus, what's the derivative of tan x? It is secant squared of x. All of this divided by 2 minus tan of x all squared. Now I will slightly simplify this. I will just remove the 0 here. This will give us negative x times negative secant squared of x, all divided by 2 minus tan of x, all squared. Now let's move to another example. Let's say f of w equals to 1 plus secant of w divided by 1 minus secant of w. Again, we will use the quotient rule because this is a fraction. So the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator divided by the denominator squared. So let's find the missing derivatives. The derivative of 1 plus secant w, first the derivative of 1 is a constant, so it's 0. The derivative of secant w is secant w times tangent w. Now let's find the other missing derivative, the derivative of 1 minus secant w. Again, derivative of 1 is 0. Derivative of negative secant w, negative stays outside. The derivative of secant is secant w times tangent w. All of this divided by 1 minus secant w, all squared. Let's move to our final example for derivatives today. So given f of x equals to e to the power of sine squared of x squared. Let's find the derivative of f of x. So, usually we say e to the power of x, its derivative is e to the power of x. However, here, it's not e to the power of x, it's e to the power of sine squared of x squared. In this case, this is where we use the chain rule. So we take the derivative of e to the of e, which is usually stays the same. So we compute it at sine squared of x squared. Basically, we're taking the derivative of the outside computed at the inside times the derivative of this inside. So times the derivative of sine squared of x squared. Now I just wanted to point out that sine squared of x squared, we can write this as sine of x squared, and we can square it outside. So this is the power rule. Now we drop the power and we get sine of x squared to the power of 1. And then here we will use the general power rule. So after we drop the power, usually if we drop the power when we have x squared, we drop the power and we get 2x. However, here we don't have x squared, we have sine squared of x squared. So when we drop the power, and yes, we get sine of x squared, however, we also have to take its derivative. So what is the derivative of sine of x squared? So first I'm rewriting the entire thing. What is the derivative of sine of x squared? The derivative of sine is cos. I evaluate it at x squared, and now I have to take the derivative of x squared. What is the derivative of x squared? It is 2x. And this is our answer.